Hi guys, so this is our lesson 9.5 note. If you haven't printed they should be attached to your previous notes. So 9.4 and 9.5 are together, 9.6 will be separate. So you'll have two files to print there or write them on paper. So you have those to look back on as you work through your big ideas assignment. Okay, so we talked about tangent in our last lesson. We're going to talk about sine and cosine today. And again, we're going to need our calculator. So we're going to find the sine and cosine ratios. We'll use them. And they're used in special right triangles, or only in right triangles. And then we're going to use them in real life examples also. Okay, so like before, I'm going to move this out of the way so you can see those. I'm not going to pause the video for the vocabulary. So take your time, pause, and write down all that you need, okay? So the sine is the trig ratio of the opposite leg over the hypotenuse from an acute angle of a right triangle. Cosine is the trig ratio of an adjacent leg over the hypotenuse from an acute angle of a right triangle. Now remember last time when we did tangent, we didn't use the hypotenuse at all. We only used the legs, opposite and adjacent legs. So our sine and cosine, they use the hypotenuse, and they'll use either the opposite if it's sine or the adjacent leg if it's cosine. Okay, and then with our tangent, we had an angle of elevation. With sine and cosine, we have angles of depression that we talk about. So if we're up on top of that second story or third story building and we look down, that's our angle of elevation. So it's the downward line of sight. Okay, abbreviations. Sine, we just write S-I-N. We don't say sin because we're all sinners, but we don't sin in the classroom. So it is still sine, even though it says sin. Okay, so sine is S-I-N, cosine is C-O-S, and the hypotenuse is H-Y-P. Notice we're using lowercase letters for all of those things. Okay, so here is a right triangle. The sine of A is the ratio where it's the opposite leg over the hypotenuse. And the cosine of A is using the adjacent leg over the hypotenuse. Okay, so if we look at sine of A is the opposite leg, which is BC, over the hypotenuse, which is AB here. And then our cosine of A, cosine is the adjacent leg, which is AC, and hypotenuse, again, is AB. Okay, so if we are going to find the sine of S, the cosine of S, the sine of R, and the cosine of R. So we're going to write them as fractions and as decimals using 4 decimal places. 4 decimal places, why? Because we have to think about those good old days where we had the books with lots of tables. Okay, so if we start with the sine of S, we have to start with angle S. And looking at angle S, remember sine is the opposite over hypotenuse. So looking at S, the opposite side is 63, and the hypotenuse of the triangle is 65. So there's our fraction. We can't simplify it. There's no common factors. And then we just type that in the calculator and we get 0.9692 to 4 decimals. All right, cosine of S. So looking at angle S, cosine is the adjacent over the hypotenuse. So from S, we look at the adjacent leg, which is 16, and our hypotenuse is still 65. They do not share any common factors, so there's our fraction. And then we type that in the calculator to get our decimal, 0.2462. Now sine of R. Sine of r, we have to change our point of view and go to angle r. Sine, remember, is the opposite over the hypotenuse. So from angle r, the opposite is 16, and our hypotenuse is still 65. No common factors. Notice it's the same thing as we did above. So we type that in again, and we still get the same answers, 0.6462. All right, and then our cosine of r, when we're looking at r again, our adjacent, not opposite, our adjacent is 63, and the hypotenuse is 65. Notice that's the same as our sine of s. So if we type it in again, we're going to get the same decimal. You think that's always going to happen? The sine of our angle is equal to the cosine of the opposite angle. The sine of the angle is equal to the cosine of the opposite angle. Okay. The sine of the acute angle is equal to the cosine of its complement. So the opposite angle in the right triangle is always a complement because we have a right angle, right? So that's 90 degrees. So the other two angles have to add up to 90. So those other two angles are always complements of each other. So the sine of one angle is equal to the complement, the cosine of its complement. Oops. I don't know what I'm doing. Okay, so we're going to let A and B be complementary angles, and then following statements are true. The sine of A is equal to the cosine of 90 minus A, or the cosine of B. And vice versa, the cosine of A is equal to the sine of 90 minus A, the complement, over the sine of B. Same thing, just different angle. Okay, so we're going to write the sine of 60 in terms of cosine. So the sine is equal to the cosine of its complement. So we have 90 minus 56. To find the complement, cosine would be 34. And then write the cosine of 27 in terms of sine. So it's cosine of 27 is equal to the sine of the complement. So we do 90 minus 27, which gives us the sine of 63. Okay, so find the value of x and y. We're going to round to the hundredths position. Okay, so we have our angle, our given angle, and we want to find x. Well, x is the opposite leg over the hypotenuse. So our sine, angle, goes with the sine. So the sine of 26 is equal to x over 14. So we're going to cancel the fraction by multiplying 14 on both sides. And then we put that in the calculator, 14 times the sine of 26. I was going to do this on paper. So I'm going to go to paper. Okay, so our sine of 26 is equal to x over 14. We canceled the fraction by multiplying 14 on both sides. And then we need to put this in the calculator. So we do 14 times sine 26. And we get 6.137. So that would make it round to 4. Okay, and then we want to look for y. Well, y is the adjacent leg, and so using adjacent means we have to use cosine. Our angle measure is 26. Adjacent is y over the hypotenuse, which is 14. Cancel the fraction by multiplying on both sides. And then we put this in our calculator, 14 times cosine of 26. Y equals 12.583, so that stays an 8. Okay, so you'll, on almost all of these sine, cosine, tangent functions, you're always going to get a decimal. Hardly ever do we get a whole number. So decimals are going to be commonplace. Okay, our angle of depression. The angle formed by the downward line of sight with the horizontal line. So if you at the top of the lighthouse and you're looking down at the boat, you have your straight ahead sight line, right? And then looking down at an angle of 27. Okay, the angle of elevation was the opposite of that, right? We would be on the boat and we have a straight ahead sight line at the ground, but we look up at the lighthouse. So your straight ahead sight line at the top of the lighthouse and your straight ahead sight line on the boat, those are going to be parallel, right? They're both going to be 90-degree angles here. So if we think about the angle of depression and the angle of elevation, those are alternate interior angles, and they're going to be the same angle. Okay, so the angle of elevation and the angle of depression are alternate interior angles. They are the same. Okay, so let's look at our skier here. This says not drawn to scale. You're going to see lots of that in geometry. Because if this really was 12,000 feet, that would be a giant person there. All right, so you are skiing on a mountain with an altitude of 12,000 feet. The angle of depression is 21 degrees. So the slope of that hill is 21 degrees. The height of the mountain, or the height of you, is 12,000 feet. We want to find the distance you ski down the mountain to the nearest foot. Okay, so if I know the elevation, I know a side length, I know an angle, I can use a trig function. A side and an angle is what you need to solve for any other part of a triangle. Okay, so if I look at my angle, I know the opposite, and I know this is the hypotenuse, because here's my right angle, right? So this is the hypotenuse. I know the opposite and the hypotenuse. So that means I have to use the sine. Our degree measure is 21 equals, the opposite was 12,000. Oh, not 12,000, 1,200. And my hypotenuse is what I don't know, it's the x. So solve for, get rid of the fraction by multiplying by x. And then I want to solve for x by, let me rewrite that. We'll solve for x by dividing by the sine of 21. And then I just have my calculator now. 1,200 divide by sine 21. 334, nearest foot, right? Nearest foot, 8.5. So that's going to make it go up to 9. Okay, real quickly, I'm going to show you on the standard calculator. Again, 1200 divided by, put your angle in first, 21, then sine, then equals. And you see you get your same answer. Okay, example 5. We have our park ranger performing fire observation duty from a top of a tower here, which is 90 feet high. Our tower is 90 feet. He spots a fire in the distance at an angle of depression of 7 degrees. So that's this angle here. He's looking down at 7 degrees. So he has one of those little spot glass things that has the measure of angles on it. If you watch a movie, a C movie, they usually have those on there. If you look up surveyor equipment, you'll see some of those on there. So he had that looking out from his tower, and then we know the distance of the tower. Now, to use trig functions, we have to know an angle of the right triangle and a side of the right triangle. So we know the side of the right triangle, and we don't know either one of these angles immediately, right? But we do know this angle is not inside the triangle. But we do know that these are parallel, and the angle of elevation is going to be the same angle. Okay? So you could think of it that way. But you also know, and you can think of it in different ways, this is a right angle, right? Your line of sight straight ahead to your height down is a right angle. So you have 7. This is 90 minus 7, so this angle is 83 degrees. Okay. Now you can pick which angle you like to use better. I like to do where I don't have to do any extra math, so I just know these are the same. So I'm going to use this angle for my calculation. Okay. But you could do it the other way. Remember, like we said earlier, the sine is this of one angle is equal to the cosine of the other angle. So it doesn't matter which angle you use, you're going to get the same answer. Okay, so I'm going to use this angle. From this angle, opposite is my 90 degrees. Okay, and the x is what I want to find here. I want to know how far away the fire is, right? So I have an opposite, and this is a leg. It's not the hypotenuse. I have an opposite and an adjacent. Remember, opposite and adjacent, no hypotenuse means I'm using the tangent. Okay, so we have the tangent of 7 degrees equals, opposite was 90, and my adjacent is x. So cancel the fraction by multiplying by x. So I get x tangent 7 equals 90, and then solve for x by dividing by the tangent of a 7. And then it's time for the calculator. Okay, I'm going to use this one first because it came up first. So 90 divide 7 tangent equals nearest how far is it from the tower? It doesn't tell us, so we'll use 2 decimal places. Okay, so that's 732.9 feet. All right, example 6. We want to solve for x and y. Okay, so with our x, we have our given angle. So you always start with that given angle. From that given angle, I have opposite is my x. And the other known value is this 9, which is the hypotenuse. Right? So I have an opposite and a hypotenuse. Opposite over hypotenuse means I have to use the sine. And my given angle is 16. Opposite was x. Hypotenuse was 9. Get rid of the fraction by multiplying by 9. And then I can just multiply. I'm going to continue with this calculator just because I think y'all can do it on the regular graphing calculator. 9 times 16 sine equals. Didn't tell us what to round to, so we'll do 2 decimal places. X equals 2.48. Okay, now our y, we want to solve for y. With our given angle, y is the adjacent. And our other known value is our hypotenuse. Now, yes, we did find x, but we had to round to get that x. So we always want to start with, if possible, we always want to use the given data, okay? Because you'll get some rounding errors. And with big ideas, if you're 1 decimal point off, you're wrong. So we don't want those rounding errors, right? So we're going to use that 9, our hypotenuse. We have adjacent and our hypotenuse, which means we have to use the cosine of our given angle. Adjacent was y, hypotenuse was 9. So we'll get rid of the fraction by multiplying. And we put it in our calculator. 9 times cosine of 16, 8.65. Okay. Now our last one. Okay, solve for C and D. It says use the sine and cosine functions only. You cannot solve for C without the hypotenuse. Okay, so sometimes you might have 1 or 2 questions that tell you to use sine or cosine only. Okay, so it's going to make an exception to our rule that we just talked about up here. So let's find C. C, here's our given angle, right? So from our given angle, C is the opposite. And then our other known value is 10, but 10 is the adjacent. But it says use cosine and sine and cosine only. Opposite and adjacent, that's tangent, so I can't use it. Okay, so that means I need to know D. So we have to start with D. So we have 47 as our angle. Our known value is 10. So if we start with, that's our adjacent, sorry, I shouldn't have erased that. Our adjacent and our hypotenuse, D. Okay, so cosine is our adjacent over hypotenuse. So we're going to use cosine of 47 equals C over, sorry, C was adjacent is the 10, not C. My fault there. Adjacent is 10, which I scratched out, 10, and our hypotenuse is D. Then we cancel our fraction by multiplying D, and then we divide by the cosine of 47. So D equals 10 divided by the cosine of 47, which equals 14.66. Okay, now we're rounding. Right. Okay, now to find C with sine and cosine only, right? We're going to have to break our rule and use this rounded number to find C. So C is our opposite, and it wants us to use sine and cosine only, so we have to use this hypotenuse. So opposite and hypotenuse, which means we're using sine over here of 47 equals the opposite was C, hypotenuse was 14.66. So we cancel our fraction by multiplying that 14.66. And then we can type that in the calculator. 10.72. All right. Well, I hope that made sense. If it doesn't, please ask, and I will hopefully see you guys soon.